Hey everyone, welcome to the second video on cylindrical shells. And in this one we'll be going through another example and then talking about kind of shells versus washers sort of scenarios. Just a quick recap. What I want to do is show you kind of what we did in the last one, which is if you're considering a region, this one's going to be rotated around the y-axis. A lot of times what we'll do is we'll kind of break that region up into rectangles. And so there's maybe several rectangles, and then we'll take those rectangles and rotate them around the axis, see what they look like. So if this red one goes around, then what we get is, in this scenario where my rectangles are parallel to the axis of rotation, we get what's called a cylindrical shell. And notice that this is hollow on the inside. Normally these rectangles we consider are super thin, so there's not a whole lot of thickness to it, just like a little dx piece right there. And then we do 2 pi r to get the circumference and the height, and times the thickness. That gives us the volume. So you can think of it as kind of slicing this rectangle right here, unwrapping it, so this cylinder forms a rectangle all the way around. Cutting it and then it getting stretched out. So we get 2 pi r circumference times the height times the thickness dx. So that's the formulas we're going to be using throughout this video. So if we come back over here to this solid, we're going to be looking at what is the volume of this solid using shells. And we've done something similar to this with discs, but this time we just want to compare what does it look like with shells. So first off, the axis of rotation, right, looks like for this parabola, the axis of rotation is going to be right across the bottom, right there where it's going to go around. So we'll say that's going to be on the x-axis, and I'll go ahead and sketch that in. So this is our axis of rotation right there. And if we're going to use shells, we're going to be doing something that's parallel to that axis of rotation. So here's my small little rectangle I'd normally use right there, and that's going to get rotated around the x-axis. I'm going to say right there x-axis, or y equals 0 if you like the equation form. We just want to sketch out an idea of what's going to happen. So this is going to rotate around. This is not really to scale. It should go all the way down to number 2 right here, but kind of gives you an idea. So right across the bottom, that's where that rectangle is going to go. And what we're looking at on this is, remember the 2 pi r, so we need this radius coming up here. What is that r? And the height of this cylindrical shell will be whatever the length of that rectangle is. So I'm just going to label that h right there. And normally what we'll do is we'll look at, all right, I have, say like this, x2 and x1, or x right and x left, whichever way you want to label them. I'm just going to take this bigger one minus the smaller one to get that length or that height. And then the r, in this case, we'll just consider this is a y value, right? So this is just y, and the thickness of my rectangle is going to be dy, so it's fine to leave this as y. I don't need to replace it with this x equation up here. We're going to leave it as y because I'm dealing with the dy. I want everything in terms of y. So that's what we're looking at for that radius. So most of the work on this one's going to come down to finding this x1, x2, subtracting it, getting that height. Let's go and do that real quick. On this one, actually I'll go ahead and do that over here on the side. So I'm just going to rearrange this equation for x. So we'll get, say, y minus 4 negative x minus 3 squared. Divide by the negatives, we got negative y plus 4 is this x minus 3 squared, and then square root with y plus 4. It's going to be this x minus 3. And then don't forget, when you do a square root, you need that plus or minus in front right there. And then I'll go and add 3. We got 3 is this, or sorry, 3 plus or minus that square root. So we got negative y plus 4 inside that root. That is going to be our x. So we get the first x, remember, is going to be right here from 3. We're going to add the root. From the 3, we're going to subtract the root. So that gives us our different x1 and x2 that we're going to use. The height on this one, we'll go and say the height is x1 minus 2. And go and replace those. So this is going to be 3 plus the root. And I'm going to kind of shorthand this for a couple steps. So 3 plus that root minus 3 minus that square root. And when we distribute the negative, that's going to be now 3 plus the root again, minus 3. Negative times negative will make this plus that square root. And lo and behold, 3's are going to subtract out. And we just get a couple of these identical roots right here. So height will end up being 2 times that square root. And I'll go and fill it in. Of either 4 minus y or negative y plus 4, whichever way you'd like to write it. It doesn't really matter. So negative y plus 4 we'll say is that height. So go ahead and put all those together. So we got r is our y, h is this 2 times the square root of negative y plus 4. So the volume of a general sample shell is going to be this 2 pi r. Actually, let's just write 2 pi r times h, in this case, times dy. We'll replace those now with 2 pi times y times this 2 square root of negative y plus 4, all under the root, and then our dy. Alright, so that's one sample shell. And then we'll go and integrate that. It looks like the y's are going to go from down here at 0 all the way up here to 4. So just run your y's, since that's our variable this time, from the bottom to the top, 0 to 4. And put that in. So we got 2 pi y times 2 times that square root. This way, square root of negative y plus 4. And yeah, you could simplify a little bit, 2 times 2 is 4, but really I'm just going to plug this into a calculator Desmos anyway, so we'll just leave that and go ahead and calculate that out. I went ahead and put that here in Desmos, and I get 107.233. So that's what I'll go ahead and write down. So 107.233. And that'll be cubic, whatever, inches, meters, feet, whatever you have, by cubic units on that one. So that's kind of the idea. Now, one thing I wanted to highlight here is we've done something similar to this before. This is our very first one when we were talking about discs and washers. And it would be a lot easier to just use vertical rectangles here without having, and just use disc rather than having to go through all of this rearranging and everything to use shells. So this was just an illustration of what shells looks like when you have to rearrange equations and stuff like that. It's still 2 pi r times h. But one of the questions that we want to look at is, when should I use discs? When should I use shells? When should I use washers versus shells? That sort of thing. So we'll go ahead and take a look at that on the next page. So compare your work for the end results of objects 3 and 4. That was in the last video where we looked at with the shell going one way and this time the shell going the other way. What did you notice? One thing you should notice is that there's a lot more work involved on number 4. The reason for that is I had to rearrange that equation in terms of x, right? I had to get the x equals on that one. So It was a lot more work to use shells for that particular object just because I had to do all the rearranging of the equation. Consider the scenarios from the discs, washers, and shells handout. What rules could you make for determining if you're using discs, washers, or shells? Think about that for a second. Go ahead and pause the video. Think about it. Put an answer down. I'll go ahead and write one down as well, and you can maybe compare, see if you're matching what I'm thinking. All right. So hopefully you came up with something to this effect. Discs and washers, your rectangles are always perpendicular to the axis of rotation. And with shells, your rectangles are always parallel to the axis of rotation. And these symbols here are geometry shortcuts for perpendicular and parallel, in case you're not familiar with those. But it's really all about what is the rectangle orientation and with respect to the axis of rotation. So perpendicular, you're doing discs or washers. If there's no gaps at all between the rotation axis and the object, then you have discs. If there is a gap somewhere, then you're going to have washers. Shells, your rectangles are always parallel. Doesn't matter if there's gaps or not. As long as they're parallel, you are using shells. So it's not really about anything in particular other than how do those rectangles look compared to the axis of rotation. Alright, if we take a look at the next one, given a region and an axis of rotation, which would be better to choose first, your method or your sample rectangle? And I'll go ahead and let you think about that one. Again, pause the video, think about it, maybe write something down, and then see if what you get compares to mine. Alright, so hopefully you answered rectangle, right? If you're thinking about method, like I want to just use discs or I just want to use shells, you can kind of get into trouble that way. It's best to think about your rectangle first. How do I want to draw my rectangle on this region? The purpose of that is you want to avoid rearranging equations if at all possible. So just like on the last one, if I were given this without saying a specific method of use shells or use discs or anything like that, I would definitely draw my rectangles vertically, and to avoid rearranging this equation, right? I can just grab the y value off of that and change it into x really easily if I have vertical rectangles. But with horizontal, I have to go through quite a bit of work. So I'm going to try to avoid using horizontal rectangles with this one if I can. And if my axis is the y-axis, then I'm parallel. I might use shells, just like on number 3. But otherwise, you know, I might use discs or washers, depending on if there's any gaps or not. So it's really good to look at what are my rectangles going to look like, and then see what corresponds with that axis of rotation. Am I perpendicular? Am I parallel? And then I know if I'm going to use sort of this disc, washers, or shells after I picked my rectangle orientation. Last question here, we'll just do real quick. Which is easier to use, washers or shells? Well, it really depends on how you set up your rectangle, right? If it's easier, if you don't have to rearrange equations, I generally consider that easier. So if washers requires no rearrangement, that's going to be easier. If shells requires no rearrangement, that's going to be easier. So it all depends on how you drew your rectangles and which way the axis of rotation is going as to what's going to be easier to use. So you can just put depends on that one. Alright, well that'll do it. The next video will have a couple more examples where the axis of rotation is not the X or Y axis. So be sure to check that out.